Lesson 3, Module 3, student page ML1. What sequence does A in the n plus 1 equal an minus 3, given that A1 is 5 and yield for anything greater than 1? So what we want to know is A2, is we put a 1 in there, equals A1 minus 3, which is 5 minus 3, which is 2. If we do the recursive sequence again, we can say A3 with a 2 in there is A2 minus 3, and we know that A2 is 2, subtract 3, and we get a negative 1. So what we know is our series starts 5, 2, and negative 1. 5, 2, negative 1, so it looks like we're subtracting 3, negative 4, negative 7. Those are all reasonable values to predict. On this one, it looks like this time we're adding 3. If you think about it, the new term is the old term plus 3. So if the A sub 1 term is 5, then the next term must be 8, because it says to add 3. So our series is going to go 5, this time it's going to go up. 8, 11, 14, 17, etc. Johnny suggests that they plot the sequences to help them understand the patterns. So now what we're going to do is we take a look and see what did they discover. So the A sub 1 term, the first term of this sequence is 5. Then the next one is 2, down to negative 1, on down to negative 4, and then here to 7. All right, and then in the second set, we go 5, first term is 5, up to 8, up to 11, up to 14, and up to 17. And now the sequence is ascending. This one fell down, this one's going up, but they're all fairly straight, and we like that. So here's a little bit of the beginning of a definition of an arithmetic sequence. The sequence is called arithmetic if there is a real number d, such that each term in the sequence is the sum of the previous term in d. Arithmetic sequences are often called linear sequences. And that's something, oh, sorry guys, I was just trying to underline. And that's something some of you discovered in the last lesson, where sometimes the lines were straight and sometimes. Now look at this sequence 1, 3, 9, 27. What do you notice? And what I'm hoping you notice more than anything, what the first thing is that this is multiplying by 3. Now we're not adding, but we're multiplying. I can do this, multiply by 3. And what happens is that makes it different because the spacing is not even. If we graph this one, we get a very different look than the last one. Our first value is at 1. Our second term is at 3. This is a very strange graph. It's got 4 spaces in between. Okay, so 3 is a little bit like about here. I apologize for that. I don't know how I managed that one. At 3, we have a value of 9, so a little bit up from there. At the fourth term, we're all the way up to 27 for our value. So what you can see, and see 27 probably a little bit like here, is that our points are no longer in a straight line. Is the same number added to each term to get the next? Our answer is no. Is it a linear sequence? No. Is that okay? Yes. Sequence is called geometric if there is real number r such that each term of the sequence is the product of the previous term r. This is where you have to remember product means multiply. And we already discovered that we were multiplying by 3, so it says, is this a geometric sequence? And the answer is Not no. Why am I going to write no? Yes. Try to write a definition of a geometric sequence in your own words. Write it here and then send it to me in the answer key. So this is lesson 3, module 3. This is student page 14. Think of a real-world example of an arithmetic or geometric sequence. Describe it and write its formula. I'm leaving this one up to you to answer in Edpuzzle and test your answer out here first. All right, and finally the last question. If we fold a rectangular piece of paper in half multiple times and count the number of rectangles created, what type of sequence are we creating? Well, here it is with no fold at all. So that's A sub 1, and what we have is 1 rectangle. If we fold it in half, there we go. Well, that didn't go very well. I guess we'll just do this. Oh, I'm sorry. A2, after our first fold, we have 2 rectangles. Now, if we're going to fold it in half again, that means we're going to have to maybe fold it another direction. And you can see that A3 would give us 4 rectangles. Now, if we fold it in half again, that means all of these guys are going to get halved up too. So this guy here, you're going to have to imagine what it would look like. Will be here, and we get A4 is 8. Hopefully you're seeing a pattern emerge. I think I'll go ahead and give it one more halfie. So we'll have those guys and we'll have these guys. Then we can see A5 is 16. So is this a geometric or a linear sequence? And I hope that you came up with geometric because it's increasing by multiplication. Geometric. I can spell really, I can, not really. Okay, so what happens? Well, A sub n, it says, what do we want? Can we write a formula? Well, the generic formula would be basically a to the n is 2 to the n minus 1. That would give us our formula. I hope you like it.